This is Rohan and today we are going to check out when lava meets ice. So definitely ice means it's very cold, lava means very hot. So two opposite things are going to react. So we'll just check out what happens and then we'll discuss. Okay, here we go.
Our next experiment embraces one of the most dangerous forces of nature. Almost 4 million people have watched red-hot lava meet ice. We caught up with artist Bobby Saki and geologist Jeff Carson and their rumbling lava furnace to ask them what they thought would happen.
I had no idea what it was going to do. No idea at all.
The first guess is always it's going to explode. Always number one. Or it's going to tunnel down, it's just going to dig right through the ice, melt a hole in the ice. And of course, it didn't do any of those things.
I was stunned by what it did when it hit the ice. And you see the bubbles, bubbles this big, and then there's bubbles within bubbles.
The scrambled eggs from hell is the way it looks in that video. And just did things we just didn't really expect.
So why are volcanic bubbles formed?
The lava is so hot that when it's poured onto the ice instantly turns not just into water, but straight into steam.
Now, this steam has to escape, so it bubbles through the lava. So while it looks like the lava itself is boiling, it's actually the steam being produced that is trying to escape.
As the lava cools, we start to get a thick black layer forming on top, and this starts to trap those bubbles of superheated steam inside the rock, and it's kind of like a natural form of glass blowing.
But how does the lava crawl across the ice? Shouldn't it melt right through?
The formation of all of this steam helps the lava to flow because it means that it's sitting on top of a blanket of steam rather than in contact with the ice itself. And this means the friction between the lava and the ice surface is very low.
Now Bob and Jeff are taking things to the next level. It's lava versus water.
Wow. We've done over 100 pours into water, onto ice, onto sand, onto snow.
We're learning a lot. There are things that are happening here that we had not anticipated. It's beautiful stuff.
Stand back. That sputtering lava's over 2,000 degrees Fahrenheit.
We just finished watching when lava meets ice, and definitely in the video it was when lava meets water also. So it's my first intuition was that water will eventually, or ice will eventually cool down lava. Given enough water or ice, lava has to cool down. But what I saw was very different. Like as they explained, like when the lava hits the ice, it immediately converts into steam rather than water. So it just does not go to the second level of the heating from ice to water, then water to steam. It just directly go to steam, and it has to escape quickly. So it tries to, but it could not because there is lava above that, so much lava, dense lava. So it forms a kind of a bubble, and then the lava rolls upon it and keeps on moving. So eventually it's cooled down, but all the bubbles which you see, you can't touch them even after a long time because inside it there is a hot steam. So I don't know how much time it will take, or what will be the process to make all the lava eventually cool on the ice. They have not explored that in the video. Another thing is that when they pour in the water, it cooled down, but it becomes a black shady things. They didn't explain thing, but I think the lava cools down. Whatever heat is there, the amount of water it requires to get cooled down, so that water will convert it into steam and it will flow away, and the water will become very hot. But eventually after a time, it will get cooled down, but it has to cool down. That is the process, equilibrium process. All the temperature, if it's high, it is a low temperature, it has to come to an equilibrium, and the overall equilibrium is the room temperature around you. So it will come to the room temperature eventually, given enough time. Okay, so that's it, guys, for today. Till next time, take care. Bye.